Electro-Coll. Your teacher Collins Odinga is back again, and today I want us to look at the angle determination using Phasor diagram, which is a continuation of my last tutorial, which I talked about the measurement of power using 2 watt-meter method. So we considered and we saw that we had the measurement of power was done using two line voltages, and we had a current that was actually affecting the same. Now today you can remember that we talked about the voltage VRB and the current IR, and we wanted to know what angle does the voltage VRB and IR make. And if you look at this Phasor diagram, we are having the Phasor voltages, which is VBN, VRN, and VYN, which are 120 degrees apart from one another. Now we are interested in finding the angle between VRB and IR, and we normally know that the angle between the line voltage and the phase voltage is normally 30 degrees. Now here, this angle here is an angle 30 degrees, and again we are having VYB and VYN. This one is a line voltage and this one is a phase voltage. So of course they are separated by also an angle of 30 degrees. So in this particular scenario, VRB is a voltage between this phase voltage and this other phase voltage. This negative VBN, it means that we're having VBN but at the inverse. It is inversed. So that is mean it has changed the direction. That is why we are using a negative. So the VRB, which is a line voltage, is a voltage between the VBN and VRN. So in other words, VRB is equals to VRN minus VBN. In the same way, wattmeter 1 was involving both VRB and IR. So wattmeter 1 was involving VRB and IR. So we are interested in the angle that VRB and IR make with each other, which will be now this. An angle between VRB and IR, VRB and IR, which is this angle. So we are interested in this angle. And also in the same way, VYB is between VYN and VBN. So this one is equals to VYN minus VBN. So what is the wattmeter 2 reading? So wattmeter 2 reading was giving us the line voltage, which is VYB, considering IY. In other words, the wattmeter reading was equals to the line current times voltage, times line voltage. So wattmeter 1 will be VL IL cos an angle between VRB and IR. Wattmeter 2 is equals to VL IL cos an angle between VYB and IY. So if you look at wattmeter 1, this angle here is the area of our interest. And remember, the whole angle between this and this is 30 degrees, and this is phi. So it means this angle here will be 30 minus phi. And if you consider this other one, we are interested in the angle between VYB and IY. And for you to get that angle, it will be 30 plus phi. So in other words, wattmeter 1 will be equal to VL IL cos 30 minus phi. And wattmeter 2 will be VL IL and in trigonometric identities we normally know that cos A plus B is equals to cos A cos B minus sin A sin B. That will be equals to cos A cos B minus sin A sin B, and cos A minus B will be giving us cos A cos B plus sin A sin B. So I want us to begin with the first expression, that is cos 30 minus phi. So for cos 30 minus phi, so this one will be our A and this one will be our B. So this one will be equals to cos 30 cos phi plus sin 30 sin phi. If you consider the laws of trigonometry, we normally know that cos 30 will give you root 3 over 2, and this one will remain to be cos phi, plus sin 30 is 0.5, which is a half, so it will be plus a half sin phi. So this is the first expression considering the trigonometric identities. Then the second one will be cos 30 plus phi. So for cos 30 plus phi, it will be cos 30 cos phi minus sin 30 sin phi. So in other words, what you're going to have here, and this one remains to be the same, so cos 30 will be root 3 over 2 cos phi minus a half sin phi. So we want to now combine the two expressions so that we get the summation that we are interested in. So in this case, we're going to have, so it was cos A, so we are back to here. So cos 30 minus phi is giving us this, and cos 30 plus phi is giving us this. So in other words, we are going to have VL IL into root 3 over 2 cos phi plus a half sin phi plus this other expression plus root 3 over 2 cos phi, then minus a half sin phi. If you look at this expression, this and this will cancel, then you remain with the two of this. So this one will give you VL IL into root 3 cos phi. That is, if you do this and this, if you add the two, you'll realize that you'll find that is root 3 cos phi. So that is after getting the summation. So subtracting what beta 1 minus what beta 2, you are simply going to change the sign here, whereby now at this particular point you'll have a minus. So in other words, you're going to have root 3 over 2 cos phi plus a half sin phi minus root 3 over 2 cos phi minus a half sin phi. So in this negative sign will affect everything inside the bracket. So this one obviously will be changing to a positive because there will be a bracket here. So when you open that bracket, it will come to a positive. So this one comes to a positive sign. So in this particular case, this and this will cancel out. And again, now we are going to have a half sin phi plus a half sin phi. So meaning we are having 2 over half sin phi. So this a half, so it will be 2 times a half sin phi. So this will cancel this so that we remain with, remember we are having VL IL outside the bracket. So it will be VL IL sin phi. And this one becomes our equation 4. This other one, the VL IL into root 3 cos phi was our equation 3. So for us to get the expression for Phasor diagram or for Phasor representation, we are going to divide equation 4 and equation 3. So in that case, equation 4 was wattmeter 1 minus wattmeter 2, giving us VL IL sin phi, and the first equation, that is wattmeter 1 plus wattmeter 2 is equals to VL IL root 3 cos phi. So dividing equation 4 by 3, we are going to have wattmeter 1 minus wattmeter 2 over wattmeter 1 plus wattmeter 2, which is equals to VL IL sin phi over root 3 cos, over VL IL root 3 cos phi. You'll realize that this and this will cancel out, and when you cross multiply, this root 3 will come this other side. So what does it mean? It means root 3 into wattmeter 1 minus wattmeter 2 over wattmeter 1 plus wattmeter 2 is equals to sin phi over cos phi. And we know that sin phi over cos phi will give you tan phi. So in this expression, it means we are interested in getting this Phasor angle. And by using this formula, you are able to find the Phasor angle using tan theta or tan phi to be equals to root 3 into wattmeter 1 minus wattmeter 2 over wattmeter 1 plus wattmeter 2. So it means you can only find the angle of this phase in a given power measurement when you already have the measurement of wattmeter 1 and the measurement of wattmeter 2. So that is how you find or you determine the angle determination in using 2 wattmeter method. And I believe you have enjoyed the lesson and the tutorial of today. I thank you so much, and I wish you a good moment. And remember to subscribe, share, like, and comment down there. I'll be able to see. Thank you so much.